Hello. Good late afternoon. Thank you for being here. No, really, thank you. Because this is the last talk of the day. It's after a 30-minute break. Got you all, loaded up on chalk tops. So thanks. Hope this is interesting to you. Hope we can explode brains in a kind of a new and different way in this last talk. So let's get started. I'm Caleb. I'm currently a software architect. I've worked at the same company for 6 years. It's called OpenX. It's an ad exchange in Southern California, Pasadena. I was a JavaScript engineer there for 5 years, and then I just transitioned to, oh no, screensaver. All right. Just got to bring up my speaker notes again. Well, looks like we exited presentation mode, so let's just go with this. Right, so I'm an architect now, which means I get to fix all the code debt I created for myself starting in 2012. And we're going to talk about taming the world's largest Trojan horse. So let's start with digital advertising. And actually, I'm curious, how many of you work directly in ad technology? OK, it's like 10, 15 people. How many of you, in the course of your jobs, have to interact with ad technology or work on platforms that monetize using digital ads? OK, so good portion. Let's define some terms. Media advertising, what is that? So we have marketers and we have audience, right? Marketers are people with goods and services that they want to sell to an audience. Now, there are many ways to go about it. One less efficient way to do that would be to just list out all the people in the world and go up to them one by one and ask them if they wanted to buy the thing, right? That's not super efficient. And so we have something called media advertising, which is where the marketer actually gets to the audience by way of something that we call a publisher, which is someone who has some kind of attention real estate, right? So it could be a magazine, it could be a billboard, it could be a website, something that the marketer can go to and say, hey, let me place my ad on the thing that all the people are looking at anyway, right? And we have brokers, which are basically, companies, people who are aggregating the markets, taking what we call the demand on the one side and the supply on the other and connecting it. And the money is going to flow from left to right in this diagram. That's media advertising. And here's a number for you. Across the world, globally, in 2017, marketers spent $500 billion, $584 billion spent on media advertising last year. That's a lot. So there's a subset of media advertising that I want to talk about for this talk, and that's called digital display advertising. So it's the same diagram, but the players are just kind of like subsets of what they were before. Our audience is internet users, people who are, connected to the internet somehow. And the marketers are pretty much the same marketers, but they're tapping into internet-connected audiences. I may have to do this every 5 minutes so I don't shut down again. Our publishers are digital display publishers, as we call them. And they're folks who run publications that are connected to the internet and that have screens, right? So desktop web app, websites, mobile apps, mobile web, connected TVs, anything that has a screen with some pixel real estate that can show display ads and is connected to the internet. And the broker is digital display ad tech. That's the industry I work in. Here's a pie chart that kind of gives some higher fidelity to that ad spend number of 584 billion. And we can kind of break it down. All the blue stuff I highlight because that's kind of a bigger category called digital in general, and it's all internet-connected advertising. So it includes things like search, classified ads. The display category is right here, right? And that's 19% of the whole pie. I'm just going to check if this thing has a laser pointer. Do we know if it has a laser pointer? No? OK. I wonder if the person who let me borrow it is here. So the blue stuff, right? What's interesting about this pie chart is that 2017 marks the first year that the digital category actually eclipsed TV, right? So the first time ever, traditional TV ad spend was at 35%. If you add these together, I think it's 40%. That's unprecedented, right? So this is a very large growing category. And digital display, which we're talking about today, is the largest chunk within digital. This is a very confusing picture, right? This is the display Lumascape, and it's kind of used in ad tech talks to kind of like wave in front of people and say, look how complicated digital display is, right? And it's really complicated, right? So this is the same kind of flow as the previous diagram, where you have marketers on one side and publishers and the audience on the other side, except all of these are actually companies that are, together they constitute digital display ad tech. It's a lot of companies. You can see the dashed lines denote acquired company, shuttered companies. Everyone's kind of merging and splitting and growing. My company is right there. It's in this middle box, OpenX. Maybe hard to see, but we're an ad exchange, which means we sit pretty much smack in the middle of this huge wall of money that's moving across, right? And I like to say this really indicates like how thriving this industry is, right? There's so much movement, so many players. Everyone's kind of jumping up with their startup, trying to get a piece of the pie. Let's talk about some numbers for digital display. 110 marketing dollars spent. 110 billion marketing dollars spent, right? So if you backed out the math from the 19% of the 584, it's about 110. Users reached on the order of 1 billion. If we just go by Facebook's last stat about their monthly active users, which was 2.2 billion, we know they're all seeing digital ads. So we're talking about like large percentages of the entire world population that's being reached by digital display. And then something called ad impression, which is really just like the occurrence of an ad, like getting from an ad server onto one of these publications. I estimate about 10 trillion of those happened in 2017. And you could say if each of these 3 or 4 billion people had 1,000 ads served to them over the course of the year, that's a reasonable number, right? 10 trillion times that an ad was actually shown to someone or marketed to someone. And that brings us to kind of the point of this talk and why this is at JSConf and not at on an ad tech yacht in the south of France, right? 10 trillion, right? This number. Why is it important? How do you get stuff? How do you get arbitrary images to show up on websites and web apps and mobile apps and stuff? JavaScript, right? So 10 trillion is the number of times that JavaScript-based ads rendered, right? And you could say, oh, well, what about mobile app, right? That's not really. Most of these things are done in web views in mobile apps, right? So we should be proud of this, right? JavaScript engineers are helping, they're the gatekeepers of this enormous, unprecedented industry. $500 billion. So round of applause, please. All of you are involved in this somehow, right? This community is powering this kind of industry. And now we get to this metaphor that the talk is built around, this Trojan horse, right? So what happens when you combine $110 billion of economic pressure with a platform that can deliver arbitrary HTML onto properties all across the world, right? Inevitably, some bad things get through, right? And I've invoked the Trojan horse metaphor, so I need to qualify myself, which is, typically a Trojan horse is, we think of it as being maliciously designed, right? So ad technology isn't, doesn't have a malicious thought behind it. However, what I'm interested in is the idea that it's kind of a nice-looking container for literally anything, right? So any code can come and run on a web page or a mobile app. And so, we as JavaScript engineers are actually, we're the gatekeepers to this kind of thing. And we have the challenge of, how do we deal with all these kind of latent consequences and undesirable code and things that are running everywhere? And that's a really challenging thing, and that's what I want to share with you today. So the talk is structured in 3 parts: construction, payload, and inversion. And I'll explain what these sections are when we get to them. Part 1, construction. We're going to talk about some really basic building blocks of digital display ad tech, right? And these are just JavaScript concepts that we're all probably familiar with, but they've kind of taken on meanings of their own in the ad tech world. And when you put them all together, then I think we'll have a better understanding of what I'm talking about. First is this thing called an add tag, right? This is just some arbitrary markup that's usually handed from some ad tech company down this way in the supply chain, right, to a publisher so that they can put it on their page. And when they put it on there, like, an ad shows up, right? And it's typically in two parts. We have something where there's like some configuration, like declared in JavaScript. This is the site that I'm coming from. These are the sizes that I want to allow in this little box. And then there's a call out to a script that's typically called an add tag, right? Or a tag library. So this is a hosted script that's hosted by, on some CDM by some ad tech company, and it's going to download the JavaScript that's going to interpret the configuration and kick off what we call like an add request, right? The process of sending an HTTP request out of the browser and getting an ad back. Now, what's important, and you can see I've kind of highlighted on the second line, HTML, grabbing some property out of the add response object, and that HTML is, it's also kind of arbitrary markup. If we think of add tags as kind of like a delivery mechanism, then iframes are in ad tech a containment mechanism, right? So we can say, I want to drop some like random markup from someone way up the supply chain into this little sandbox, and we use iframes for that. And this is a very oversimplified example because there are tons of edge cases that come in for different browsers and different situations with subdomains and all this. And typically, if you write a tag library, this is going to be one of the larger functions, and you're just going to like accrete like arcane knowledge of how to do iframes over the years. Now, if you combine add tags and iframes, what you get is the possibility of like you can actually traffic an add tag as the add response.html, and you can kind of have like never-ending chains where like what you're actually loading as your ad is not an image, but it's like another tag that calls out, and like we see these like 7 or 8 levels deep sometimes, just because of how many people are actually involved in getting an ad to show up. 2 more as far as construction goes. Cookies, right? We know and love cookies. In ad tech, they're used primarily to identify users consistently. So here's some code of a JavaScript-based cookie. But you can also do this on the server side. A server can declare that it wants to set a cookie. The idea is that it gets to store a little bit of information on behalf of its domain in the user's browser. And we can use this to consistently identify a user based on some unique ID. This would be like a tracking mechanism. And then the last one is like an analytics mechanism. We have what we call pixels, which is a misnomer, but it came from this idea that you could just kind of serve an image element that would contain some like query args, and when that image was requested, it would return like a 1-by-1 hidden GIF, right? And you'd basically just be using the fact that you could render an image, but also sneak some get variables like back to your servers, and you could have some idea of like what happened. As an ad tech company, you could say, oh, I know that the person actually saw the ad, and I know that the impression ID was 1, 2, 3, 4, 5. Now we do this more programmatically with JavaScript. This is an example from the kind of recent navigator.sendBeacon API, where we have the flexibility to kind of construct a little bit more as far as like the things we'd like to send back. All right, so I'm going to borrow from a popular meme format to kind of like round out the picture of like what it's like to be a JavaScript ad tech developer. Blanks are like the most unspecific way of reporting a bug, but you have to deal with them all the time, right? The ad's not showing up, it's blank. What do? I have to go debug. I have to go, like Amy this morning and be digging around all inside the network tab and find out why is the ad not showing up. Your code versus third-party code, this is like BattleBots, right? When you write JavaScript and put it out there on the web, you have no idea who else is going to be running in that global variable soup. I once had a bug where like there was literally a library that was the name the same as mine, and it was like confusing, like variables stepping all over each other. You have to write your JavaScript code really defensively when you're in ad tech. Network tab, you're going to be there for days. Like network tab is like burned into my retinas as like a physical location, like I've been there, Should work in all browsers. This is a big one, right? Because it doesn't matter if Internet Explorer 7 was sunsetted, 5 years ago. it's still a big enough percentage of $110 billion that you got to deal with it. You will be reading lots of minified code. You may break a major website and have to wake up and deal with it. Basically, don't merge code on Fridays because you don't want to work on the weekend. And then in the ad tech version of the waiting for it to compile trick, you can pretty much look at any website you want and just say that you're debugging it. All right, part 2. So what kinds of things are actually coming through, right? This is broken down into 3 hashtags. First is whoops, right? What are the kind of undesirable things? They're kind of benign, right? You have like a really nice, clean template of a site, and it's grayscale and modern, and then your ad comes in, right? And it's like, it makes your eyes bleed, right? You have no control over that, you know. Autoplay audio and video, right? This is a great one. You ever like, you know, like got your head down, you're working, you know, you got your Spotify going, and then there's like this weird voice that's like, and you're like, that's not part of the song, you know, what's going on? Yeah, autoplay audio and video coming through ads. Block list violation. So you're like this little guy, and you're playing Minion Rush, and then all of a sudden, ad comes in that kind of like challenges your worldview, right? You know, that's not what my parents told me, and you freak out, right? So this is like an ad quality block list violation, right? These are just things where like the person who runs this game, this mobile game, probably didn't want that to come through, and maybe even if they indicated that, it still came through. Our solution as JavaScript engineers is to build feedback loops, right? So we kind of turn to another skill that we have as front-end engineers, which is like building user interfaces. And these are some pictures from one of our tool suites called, it's called ad protection. Basically, we allow users to report an ad that they think is inappropriate, and then we aggregate these complaints and aggregate results from large-scale scanners that are actually trying to render these like on the server side, and also allow them to be forwarded to people more on this side of the supply chain, right? So if they came from other buyers that we, like as an exchange, as OpenX, that we deal with, we have a tool that kind of lets us forward the information to the right party, right? And so we're using our UX and front-end skills as JavaScript engineers to build these kinds of tools that create feedback loops. The second one is just janky, right? Which is like, I take to mean just like general low-quality things that ads cause to happen sometimes. So here's one where I was trying to click on a blog post, and then before I could click, this ad came in, and no offense to the folks at SendGrid, they're great, but I didn't want to go there, right? I wanted to go to the blog post. And this is like technically actually called page jank. It's when the page is actually re-rendering itself. Some people call it reflow. But you have no control over the code that comes through as part of this arbitrary ad markup, right? And so it makes the page do weird things sometimes. Large files, I can't even like bear to look at this, right? But no one's going to keep you from making your ad image like 50 megabytes. And so here's another one, HTTP request party, right? What if your ad markup comes in and just has tons of requests? And this is actually from a tool that we built. It's called Ad Footprint. It's a Chrome DevTools extension. You can download it on the Chrome store. And it kind of breaks things up by what types of requests are actually happening on a page. It's kind of like Lighthouse for ad tech. We break it up into content and then ad requests, so those initial requests that are going out of the browser, and then ad slots, like the requests that come from stuff within that first level of iframes that gets written out. And this kind of has a problem, right? So we dig in, go to ad slots, we categorize all the ad slots on the page, and look, this 970 by 250 is having problems, right? 12 seconds to load. So we click in there, and we can see basically, there's 36 requests. That's a lot. Probably don't need that many. And there's this one by one GIF right here that's taken almost half a second to load. So the solution to this problem of jankiness, I think, aside from building tools that let you understand it, is to make performance repeatable, right, for publishers and people building websites in general. What if we had something that would do all these things? And if you've spoken to the folks outside at the AMP table, this is actually just shamelessly copied from their website. Right? This is what AMP does. It kind of is a restricted way of writing HTML that includes some performance guarantees. And what's nice about this is not only that it's kind of relegating ads away from the main thread and making your content great, but there's also like AMP for ads, right? So you can start to specify your ads AMP documents as well. And this is really cool. I think we as a community have recently started thinking more about performance. A lot of the talks today and yesterday were focused on performance. And if we kind of aggregate knowledge into open source projects like AMP, we're going to make the web better, and we're going to solve jankiness, even if it comes from third parties. The last one is shadiness, right? Fingerprinting. So fingerprinting looks kind of benign. This is from an open source version of a fingerprinter from 3 years ago. It's basically collecting a bunch of random things about what's happening in the browser and creating a unique string out of them. So what's the big deal about that? Well, basically, there's enough kind of entropy in all the different settings and things in a browser that you can kind of mash them together and create a consistent, unique ID for that environment, aka user. And basically, if third-party cookies are turned off, you can consistently identify the user. That's kind of shady, right? If the user doesn't want to be tracked, you shouldn't be tracking them. But this stuff comes through, right, in ads sometimes. Forced redirects are one that's kind of been taking the industry by storm the last couple of years. You're on a mobile site, and then suddenly you're in the App Store, right? And there's not really much you can do about it. And this is because an ad came through that kind of exploited some holes in the browser and was able to open the App Store and try and get you to download something that you didn't want. Here's one that's top of mind, right? So on January 24th of this year, the number of CoinHive miners went up 300%. All of a sudden, right? And what was happening was that someone was abusing the DoubleClick ad server to insert some web mining code into ads that were going all over the internet and getting free coins. And this is just an example of what we call malvertising, right? It's people who are actually doing nefarious things and abusing the fact that ad tech delivers arbitrary code. Our solution is to build tools that not only render ads and see what they look like and create those feedback loops, but actually try to understand at a more of a semantic level what's happening, right? Like who called who and what did they actually do? So this comes from our data protection suite, and it's showing you a diagram of basically tag calls, right? So this is from the openx.com webpage, homepage, and there's a Google Tag Manager. There's not going to be a lot of ad tech stuff here, but you can kind of get the sense that the Google Tag Manager was called, and then it loaded a few other things, right? The Google Analytics, dynamic remarketing, some various things. And this gives us a sense, starts to give us a sense of who's actually doing what on web pages. And we've also done some work actually analyzing the code that comes through. And here we've classified a bunch of ad tags that rendered on a page and given them indexes as far as security, data sharing, user tracking, tag chaining, by actually looking at the code that they deliver and trying to understand it. And this is something that kind of only JavaScript engineers can do, because we're the ones who understand what JavaScript code looks like. And something that's really cool is that we've implemented a container that if you load tags through the container on your page, you can actually block specific behaviors that arbitrary code may try to do. So you can actually turn off HTML cookie writing or reading local storage and a number of other things. You can just block those behaviors if you want. I think that's pretty cool. So the last and quick part of my talk is just some thoughts about where is this going? What can we as a JavaScript community do to make things better? Here's some thoughts, right? So this is from the data protection tool. This is a particularly egregious example of just the spamminess of ads, right? So this is a homepage tag chain diagram of a real, widely used newspaper website. 1,665 tags and pixels that collect data do other things from a total of 114 different vendors, right? This is like crazy. This is like way too much stuff. Another thought, I saw this on Twitter just a couple days ago. Some people taking advantage of a new feature called HSTS, which is meant to help you make secure calls more often. And they exploited the fact that it stored some new information in the browser, and they were using it to do fingerprinting. And this person says, I hate how the web has devolved into a war between bad actors in advertising and engineers who are trying to push the state of web tech forward. So these last two pictures, right? They're just meant to make us think, OK, so we can kind of be in this arms race against people doing bad things and an arms race against undesirable, janky, whoopsie kind of ads. But where is the web going because of all this, right? Are we getting to a place where it's kind of like this picture, which is an artist's rendition from Blade Runner 2049, where if you saw that movie, there's like ads everywhere, right? They're plastered all over buildings in every possible square inch of available space. And not only that, they're like highly targeted to the person walking down the street. Like the ad starts talking to the guy, right? Is this the world that we kind of want to move to, right? Is this where all the economic pressure is forcing us? I want to suggest not. And specifically, I want to bring to our attention this idea of something called a native ad. Now, it has a pretty plain definition. Native advertising is a type of advertising, mostly online, that matches the form and function of the platform upon which it appears. Now, here are a couple examples of things that have been maybe mistaken for being native ads, but they're not quite there. First one is these kind of like from around the web boxes that we often see at the bottom of reading an article, where you're like, oh, that looks interesting. Oh, wait, you're right. That's not from the people who wrote the article that I just read. So it's kind of hiding. Some people call that native. Not really. It may look like the content and do a good job of getting people to click on it. It's not just returning your ad with JSON. So instead of returning markup and just rendering it how it comes, it's native. Sometimes people think, oh, that's just JSON, and then you need some actual code on the front end to like parse it and do stuff with it. Native ads may involve JSON as a response type, but not necessarily. And then there's this format that's coming around where you're kind of scrolling through a page, and then like all of a sudden like it kind of slides open, and there's a video playing. Native is not just camouflaged ads, right? Or ads that kind of jump out at you and scare you, right? So what is native then? And this is my last slide. It's just a picture of 3 ads that I think could be considered native and help us, see how we can get away from that possible dystopian future. This is from my blog, right? And I have a small blog. I write technical articles on it. I run it on DigitalOcean servers. And so I put this link on there and a couple years ago, because DigitalOcean has a referral program, and now the blog is paying for itself, right? And I think it matches the form and function of the site on which it lives. Here's one from a publication called The Verge, where I'm pretty sure this is an ad. I'm not sure, but Duolingo can now teach you how to speak Klingon. And it's it's got the same style and colors and stuff, and that's interesting to me as the reader of The Verge, and so it matches the form and function. And then last of all, Twitter is a great example, right? Because they're monetizing through the very format that the platform is famous for, which is tweets, right? And I just saw this the other day. I thought it was interesting. That United actually used a promoted tweet to tell people that they had a network outage and are working to get the systems back online, right? That's pretty cool, right? Because this indicates that the way that the platform was monetized has now become a general purpose messaging and targeting platform. And I think that's really cool. And so just final thought is that native is hard because what works on my blog doesn't work on The Verge and doesn't work on Twitter and vice versa, right? And so it requires the engineers, you and I, who actually work on these publications to do some hard thinking and have some hard conversations about how to make these things viable businesses without, selling out for clicks, right? And I think that we're all more than capable of doing that, and in the process, making the internet a much better place. So, thank you.